This is John. Say hi, John. And John smells something good in the kitchen. Let's check it out, John. This is John's mom. Say hi, John's mom. Oh, what's this? There seems to be something in the oven. It's a cookie! No, 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 says John's mom. You have to let your siblings eat it first.
What?
What's this? John needs to spend at least 2 weeks with his girlfriend before he can eat a cookie? Now what shall he do now? Now here's the problem that we're facing. John wants to eat a cookie. However, he also needs to spend 2 weeks with his girlfriend, or not she will take away his Pokemon collection, which is not good. So how do we solve a problem like this? Well, John is quite smart, so he uses this formula right here, where N is the remaining quantity, N naught is the initial quantity, T is the elapsed time, and T half is the half-life of a substance. Now let's try to match the formula with the problem that we have. First of all, John's mom baked 200 cookies. And we want there to be more or equal to 1 cookie left so that John can still eat a cookie. And we know that his siblings eat half of the amount of cookies every 2 days. His girlfriend wants to spend at least 2 weeks or 14 days with him on the holiday. Will John be able to make it back in time to eat a cookie? Well, let's find out. By subbing everything into the formula and using the logarithmic function, we can see that the amount of days it takes for the cookie to remain into 1 is 15 days. So John can happily spend time with his girlfriend and still make it back in time to enjoy a cookie. But is this formula only for John to eat cookies and to spend time with his girlfriend? Well, of course not. You'll be shocked to find out that this formula is used to calculate very important things in fields such as reactive decay, medicine, chemical reactions, and environmental science, with the more well-known one being radioactive decay. But let me give you a different question. Let's say in the field of medicine, a pain medication has a half-life of 4 hours in the body. A patient receives an initial plasma concentration of 200 mg per liter after the first dose. How long does it take for the concentration to fall below the minimum effective concentration of 25 mg per liter? Well, let's use the formula that John just used. First, let's put the initial as 200, then the remaining as 25, the half-life as 4 hours, and the time being the one that we need to find. And by subbing everything into the formula and using logarithmic function, we can see the time it takes for it to fall below the minimum effective concentration is 12 hours. In the end, although this method is used to solve many complex and important problems in the world, it can still be used to solve many simple problems we encounter in our daily lives. Math doesn't have to always be boring. We can always use it in fun and helpful ways, and we should learn to enjoy math rather than hating it. Now it looks like John has finished his calculations. Good job, John! Now it's time to celebrate.